Hello friends, welcome to Learner's Planet. Friends, this is our first session for permutation and combination. Now most of the students consider this topic to be very difficult. But believe me, it's going to be very interesting topic, right? And definitely in most of the examinations, entrance examination, good number of questions are being asked from permutation and combination. Or maybe we can say from principle of counting as well, right? So let's begin the session, and we will be taking the basics of permutation and combination before we take the problems. So let's friends, first of all, let's discuss some basic terminologies which we are going to use in the this session and the other sessions of permutation and combination. The first term is the factorial. Now what's a factorial? You might have studied in your junior classes as well. See, n factorial, as I have written over here, that is the product of n numbers from 1, right? So n factorial is what? 1 into 2 into 3 till n. That is product of all these numbers, that is from 1 to n. Suppose I have 5 factorial. So 5 factorial will be 1 into 2 into 3 into 4 into 5. Similarly, 10 factorial, it's 1 into 2 into 3 and product till 10, right? So what n factorial is? It's 1 into 2 into 3 into 4 till n, right? So product of first n numbers is actually n factorial. Product of first 5 numbers, I'm telling numbers over here as natural numbers, or we can say positive integers, right? So first 5 numbers, the product of them will be 5 factorial, right? So what is the value of 5 factorial over here? Is 5 4s are 20, 23s are 60, 2s are 120. So the value of 5 factorial is 120, right? So I hope you are clear what is a factorial. Now we define 0 factorial as 1, and n factorial is not defined for negatives or fractions, right? That means n has to be a positive integer, or we can say a natural number, right? So factorial is defined only for positive integers, right? And 0 factorial is 1, that you have to keep in your mind, right? Now friends, just do one or two problems on calculation of factorial. See, here we have to compute 20 factorial by 18 factorial, right? Now it's very simple thing. 20 factorial is what? It's 1 into 2 into 3, 18 into 19 into 20, right? And divided by 18 factorial. Now what 18 factorial is? 1 into 2 into 3 till 18, right? So all the terms till 18 will get cancelled, right? Okay, so we are left with 19 into 20, right? So quite a simple problems. So actually how do we write n minus 1 factorial by n factorial is what? See, n factorial is product till n numbers, that is 1 into 2 into 3 till n minus 1 into n. And n minus 1 factorial is what? Product till n minus 1 numbers, right? So all the terms will get cancelled except n in the denominator, so it's 1 by n, right? So similarly 20 factorial into 18 factorial. 20 factorial is product till 20. Now this is what? 1 into 9, 1 into 2 into 3 till 19. So it will be 19 factorial into 20, right? So 20 factorial can be written as 19 factorial into 20. Similarly, 20 factorial is 1 into 2 into 3, 18 into 19 into 20. Now this product can be written as 18 factorial. Yeah. And this is 19 into 20. Okay, so we can present the factorial in various manners. Now, as simple as 20 factorial is what? It's 18 factorial into 19 into 20 by 18 factorial. So, it will get cancelled. So, it's 19 into 20, right? Similarly, I calculate 10 factorial by 6 factorial into 4 factorial over here. 10 factorial, it's what? From 1 to 10 the product is. So I can write it as 6 factorial into 7 into 8 into 9 into 10, right? Divided by 6 factorial into 4 factorial is what? 4 into 3 into 2 into 1, right? So 6 factorial is getting cancelled. Then this is 4 2s are 8 and this is 3 3s are 9. So 7 3s are 21 into 10, that is 210, right? So it's a quite simple. Now in this question, convert the following products into factorial. Let's do that. It is 6 into 7 into 8 into 9 into 10. So what we do, we multiply it by 5 factorial and divide it by 5 factorial, right? So it's 5 factorial into 6 into 7 into 8 into 9 into 10, and we divide it by 5 factorial. Now 5 factorial is what? 1 into 2 into 3 into 4 into 5. Then we have 6 into 7 into 8 into 9 into 10. So what it will be? 10 factorial, and in denominator we have 5 factorial, right? So we converted this multiplication of this product or this number into factorial very easily, right? Similarly, 2 into 4 into 6 into 8 into 10, it's quite simple. 2 can be written as 2, or we can say it's 1 into 2, then it is 2 into 2, then it is 2 into 3 into 2 into 4 into 2 into 5, right? Now this is 1 2 3 4 and 5. So 1 into 2 into 3 into 4 into 5, that is 5 factorial. And then we have 1 2 3 4 and 5. 5 times 2, right? That means 2 raised to 5. 5 times 2, the 5 2's are being multiplied with each other. So it's 2 raised to 5. So what we can say, this conversion of this to factorial is 2 raised to 5 into 5 factorial, right? Now here we have to find out the LCM of 4 factorial, 5 factorial and 6 factorial. Now what's 4 factorial? It's 1 into 2 into 3 into 4, right? So it's 4 factorial. 1 into 2 till 5, it is 5 factorial, and 1 into 2 into 4 into 5 into 6, that is 6 factorial. Now just see over here, what is the LCM of 4 factorial on 5 factorial and 6 factorial? We have to find a number that is divisible by 4 factorial, 5 factorial and 6 factorial as well, right? So just look at this number. See, it's 1 into 2 into 3 into 4, right? So definitely it is this number is divisible by 4 factorial. Yeah. Similarly, we have 1 into 2 into 3 into 4 into 5. That means this number is divisible by even 5 factorial, right? Because 4 factorial and 5 factorial, they are already included in 6 factorial, right? So what will be their LCM? LCM of 4 factorial and 5 factorial and 6 factorial will be nothing but 6 factorial, right? Because 4 factorial and 5 factorial are already included in 6 factorial that we can see over here, right? So this number is divisible by 4 factorial as well. This number is divisible by 5 factorial as well. And this number is actually 6 factorial. So it's divisible by even 6 factorial, right? 6 factorial can be written as 1 into 2 into 3 into 4 factorial, or it is 1 into 2 into 3 into 4 into, I'm sorry, over here it's 1 into 2 into 3 into 4 into 5 into 6. So what I can do is, this is 4 factorial into 5 into 6, and it's 1 into 2 into 3 into 4 into 5 into 6. So this is 5 factorial into 6, right? So 6 factorial can be written as 4 factorial into 5 into 6, or 6 factorial can be written as 5 factorial into 6. So it's 4 factorial and 5 factorial are already included in this. Okay, I hope you are clear. Now let's see this question. Here we have to find out the value of x. That means first of all let's take the LCM of left hand side, and as we have already discussed, what will be the LCM of 9 factorial and 10 factorial? It will be 10 factorial, right? So if I divide 10 factorial by 9 factorial, what I'll be getting? I'll be getting 10 only. Then plus 1 is equal to x by 11 factorial can be written as 11 into 10 factorial. Yeah, we have discussed good number of questions earlier. So 10 factorial is cancelled. So 10 plus 1, 11 into 11, x is equal to 121, right? As simple as that. Here we have to calculate the value of n in both the cases. Let's take this first one. It's n plus 2 factorial is 2550 into n factorial. Now what n plus 2 factorial is? It's n plus 2 into n plus 1 into n factorial is equal to 2550 into n factorial. So it's cancelled, right? Now we have to solve this quadratic equation, that is n plus 1 into n plus 2 is 2550. Now friends, how do we solve this quadratic equation? See this n plus 1 and n plus 2, these are two consecutive positive integers, right? So we have to find two integer. Either you solve the quadratic equation, or you can like by hit and trial you can calculate the value of n, right? Now these are two positive integers which are consecutive, right? So we get the product 2550, nothing but 50 into 51, that is 2550, right? Now 50 is what? It's n plus 1, because the smaller number is n plus 1. So n plus 1 is 50, so n will be 49, right? As simple as that. Okay. Similarly, let's solve this problem. N plus 1 factorial is 12 into n minus 1 factorial. Now n plus 1 factorial can be written as n plus 1 into n minus 1 factorial, right? Is equal to 12 into n minus 1 factorial. Now it will get cancelled. Now n and n plus 1, these are further two consecutive numbers and their product is 12. Now we know the two consecutive numbers and their product is 12 is nothing but 3 and 4, right? So it's 4 into 3 is 12. So what n is? N is nothing but 3, right? So it's quite simple. And I'm sure you are clear now. Now let's take this question. If n factorial by this data by this data, the ratio is 2:1, we have to find out the value of n. Now let's divide the data. It's, if we divide this by this n factorial and this n factorial will get cancelled. So finally we will be getting 4 factorial n minus 4 factorial by 2 factorial n minus 2 factorial is equal to 2 into 2 by 1, right? So this ratio is 2 by 1. Now for 4 factorial is what? 4 into 3 into 2 factorial. So it's cancelled. Now this is 2. So, and apart from that, it's 2 into 3 into n minus 4 factorial by, or is equal to, we can say, n minus 2 factorial, and n minus 2 factorial will be what? N minus 2 into n minus 3 into n minus 4 factorial, right? So it's cancelled. Now further we have two consecutive numbers and their product is 6, right? So we know the numbers. One of them must be 2 and one of them must be 3. So the bigger number must be 3 and the smaller number must be 2. That means n minus 2 is 3. So n is equal to 5, right? So the value of n is 5. Okay. Now similarly, quickly let's calculate this. We have to calculate the value of n further. So n plus 3 factorial will be what? N plus 3 into n plus 2 into n plus 1 factorial is equal to 56 into n plus 1 factorial. So it's cancelled. Further we have two consecutive number and their product is 56. So it's 8 into 7 is 56, right? That means n plus 3 is 8. So n is equal to 5, right? So I hope you are clear about the concept of factorial. Now we come to the next point, that is next topic, we can say it's a principle of counting, right? Now let's discuss principle of counting. Now what's the term mean. See, principle of counting, there are two types of principles, that is addition and multiplication, right? And we come across the various problems in our day-to-day life when we have to decide whether in this case the two incidents or events are added or multiplied, right? Just for an example, suppose uh, there are maybe three boys and two girls in your class. Now just listen to me very carefully. Three boys and two girls are there in your class. Now the case one, suppose you have to choose a representative out of these students, right? You have to choose one representative, right? Maybe it is a boy or a girl. Doesn't matter whether he is a boy or she is a girl, right? You have to choose one representative, right? Now how many choices do you have to choose one representative out of these boys and girls? So there are three boys and two girls, so in all five students, right? That means you will choose any one of them, right? So how many choices do you have? These are five choices, right? So getting my point? So you have five choices to choose one representative, right? What you have done over here, you have added this 3 and this 2. So this is principle of addition, right? Now I take the another case. Suppose these three boys are maybe A, B, C, and these two girls are maybe X, Y. Now the next case is I have to choose one boy representative and one girl representative, right? Now how many combinations of the students I will get? See, in the earlier case I was choosing just one. Now I am choosing two, right? Now there will be combination of the girls and boys, right? So what are these combinations? See, boy A, girl X. So AX, then AY, then BX, BY, then CX, and then CY. So how many options are there? 1, 2, 3, 4, 5, 6. So we have 6 choices, or I can say 6 combinations of representatives where is one is boy and other is girl. Now here in this case, how do I get the 6? It's these 3 into these 2, right? 3 into 2. So 3 into 2 is 6. So this is what principle of multiplication. In common language, how do we talk? See, I have to choose a boy or a girl. A boy or a girl as representative. Just concentrate on this or, right? So I have to choose one person only, either boy or a girl. So in this case, principle of addition would work, and a boy and a girl. So just concentrate on this and. In this case, principle of multiplication would work. So here we have added the data, here we have multiplied the data, right? So let's take more examples of this. Now let's take some real life examples where we can differentiate between this or and, right? So suppose maybe principal of your college, or say vice principal of your college, or maybe dean of your college. I take principal. Okay, principal of your college. Now what? See, suppose there are 5 candidates, A, B, C, D and E. Now principal, the post of principal, only one person can occupy, right? So we have 5 choices, right? A, B, C, D and E. So either A or, just concentrate on this or, either A or B or C or D or E. So we will be adding these numbers. So we have 5 options, or we can say choices, right? So in how many ways can we select one principal out of these 5 principles is 5. How many ways? 5 ways, right? The next is, suppose we have to choose principal and vice principal, right? Principal and vice principal out of these 5 people, right? Now how many ways we have? Now just uh, there are, see, one person who is principal, he cannot take the position of vice principal, right? That means we have to choose one as principal and just concentrate on this and other as vice principal, right? Now what is happening? See, for first post, suppose I am choosing principal, so I have 5 options, right? Any one of them can be principal. Maybe it's A, B, C, D and E, right? Now I have chosen one, right? Now the one which is chosen, apart from that only 4% are there as remaining, right? Now I have how many choices I have for now vice principal? I have 4 choices, right? Okay, now both the things are happening simultaneously. I chose a principal and just concentrate on this and a vice principal. So I used principle of multiplication over here and I used principle of addition over here, right? Here two events are going simultaneously. That is selection of principal as well as, or selection of principal and vice principal. Principal and vice principal, right? So this is principle of multiplication and this is principle of addition. Now do not worry much about on these terminologies. In fact, it is just a common sense and you will be like getting the problem easily, right? You don't have to think much whether I have to apply principle of counting over here and principle of addition over here, which principle of counting I have to use in which case, right? It's a smooth process. After doing some problems, I think it will be cleared in your mind, right? And to be more precise, if we have to use or, then we use principle of addition, and if we are using and, then principle of multiplication is used, right? Let's take one example. Now suppose a room has 6 doors. In how many ways can a man enter the room through one door and come out through a different door? Now here just see this and, right? Two events are there, right? One is incoming and the other is outgoing. Now both the events are happening simultaneously, right? That means both the events are having with this condition, that is end, right? That means he's coming through one door and going out through the another door, right? So now when he is going out through a different door. Now when he is coming in, he has 6 choices. Now when he is going out, he has only 5 choices, because he cannot choose the same door by which he has entered, right? So while going out, he has 5 choices. So 6 incoming and 5 outgoing, and the events are simultaneous. That means both the events are happening. It's not like that either this happen or this happen. Both the events are happening. That's why we multiplied this, right? So 6 into 5, that is, he has 30 ways to do this complete event. We can say this 30 ways are there, right? And manually, suppose I have to show this. See, I have A, B, C, D, E and F, 6 doors. So he can A, come by A and go by B, A, C, A, D, A, E, A, F, right? So A, B, A, C, A, D, A, E and A, F, right? Similarly, B, C, B, D, B, E, B, F. Similarly, C, D, C, E, C, F. Similarly, D, E, D, F and then E, F. So if we are going to count, we will be getting these number of ways, right? Then we can reverse the combination also. AB, that is, instead of AB I can take BA also. That means he's entering through B and going out to from A, right? So in short, there are 6 ways of coming in and 5 ways of going out, right? So 6 into 5, 30. I hope you are clear. Now let's take this example. From Goa to Bombay, there are two routes, air and sea. From Bombay to Delhi, there are three routes, air, rail and road. Now from Goa to Delhi via Bombay, how many kinds of routes are there, right? So it's Goa to Bombay and Bombay to Delhi, right? That means now two events are happening simultaneously. That is, one is from Goa to Bombay and the other is from Bombay to Delhi. Now both the events are happening simultaneously, right? That means the person is first of all going from Goa to Bombay, then Bombay to Delhi, right? Now, how many choices one has if he is going from Goa to Bombay? There is two routes, right? And from Bombay to Delhi, there are three routes, right? So, Goa to Bombay and Bombay to Delhi. Just concentrate on this end. Goa to Bombay and Bombay to Delhi. So, 2 into 3, 6 ways will be there, right? It's very simple. We just have applied principle of multiplication over here, but simultaneously we have applied common sense, right? That is, two ways are there from Goa to Bombay and 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 three ways are there from Bombay to Delhi. So 2 into 3, 6. Okay. Now from among the 36 teachers in a college, one principal, one vice principal and the teacher in charge are to be appointed. In how many ways can this be done? So now we have to make the three appointments and the three events are going simultaneously. That means all the three events are to happen, right? And okay, one principal and one vice principal and the teacher in charge. So for the first post, maybe principal, any post we have 36 options, right? These are the 36 teachers. Now one has been selected. Now the remaining people are 35 people. So out of these 35 people, we have to fill up the second position, right? So we have 35 choices. Then now we have 34 people only because two people are already appointed. So these 34 people, and we have to fill up the third post, that is teacher in charge, with this 34 people. So anyone can take the position. So we have 34 choices. Now this has to happen and this has to happen and this has to happen. That means all the three events are to happen. That means one principal and one vice principal and one teacher in charge, right? So 36 into 35 into 34, that is your answer. You can multiply. I just concentrate on the concept. So this is your answer, right? It's 35 into, is 35 plus 1, it's 35 minus 1, so it's 35 square minus 1. So 35 into, what is the square of 35? That is 1225. So it's 1224. Now you can multiply it and get the answer. Clear? So this is what the principle of counting, right? Now we will be taking some problems based on principle of counting, where we have to just think with the common sense and our day-to-day life, day-to-day mathematical understanding we have to apply, and we have to solve the problems. Right? Now friends, before we start doing problems, I just ask you a very, very simple question, right? I always used to ask this question while I'm teaching in my classrooms, and a student think like, why I'm asking so silly and so simple question, right? But believe me, I'm not able to get the right answer in just first, maybe say first call, right? See, how many five-digit numbers are there? It's just a very simple question which I'm asking to you. You have been studying this since your grade 2 or grade 3, but then also just answer me, how many five-digit numbers are there? Five-digit numbers are there. How many? Okay, now you just guess. First of all, what you'll be doing? 10,000, then 99,000, then 99,000 minus 10,000, and blah 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 blah. Various calculation you are going to make. Now somebody would come out with the three, four different answers are there. I just write it over there. The very obvious answer is 89999. Then somebody would tell it's 9 this. Somebody would come with different answers, right? But Now how many 5-digit numbers are there? You just tell me. Now how do we calculate that? See, for 5-digit numbers we have 5 choices, right? 1, 2, 3, 4 and 5, right? Now I have to fill up each place, right? Now I have to fill up all the places, right? Now how many digits, choices of digits we have? We have 10 choices, that is from 0 to 9, right? For the first place, how many choices I'm having? See, in all there are 10 digits, so I have 10 choices, right? But in case 0 comes in the first place, we will not be getting a 5-digit number, right? So in the first place, that is at this place, we have only 9 choices. That means 0 cannot come over here. So we have 9 choices. Then at the second place, now 0 can come. In all there are 10 digits, so we have 10 choices at the second place, then third, and then fourth, and then fifth. Now we have to fill up this place and this and this and this and this. So we have to multiply all of them, and what we will be getting is 90,000, right? No addition, subtraction, deduction, nothing is required to get this answer or this answer. Do not get confused. So the answer was quite simple, that there are 90,000 5-digit numbers. But good number of students are confused, though they are studying this thing for a long time, right? So in all there are 90,000 5-digit numbers are there. Now you get this logic. Now you can find out any instead of 5, suppose you have to find out 6-digit numbers. So it's nothing but one more 0 will be there. 7-digit, one more 0 will be there. Because for the first place you have 9 choices. For other places you have 10 choices. So you'll be getting 90,000, then 9 lakh, then 90 lakh and so on. Right? So I hope you are clear with this. How many 5-digit numbers are there? This concept is clear in your mind. Now the next question is, how many 5-digit numbers are there when each digit is different? Here we have calculated all the number of all the 5-digit numbers. Now the next question is, each digit should be different, right? That means this number and this number, both the numbers are not at all allowed, right? So how many 5-digit numbers are there with each digit different? Let's do that. See, in all 5-digit numbers are 90,000, right? Now further I have 5 places and 0 to 9, 10 digits are there. Okay. Now for the first place, I cannot fill up 0. So I have 9 choices. I can take any number from 1 to 9, right? So I have 9 choices. Now for second place, if there is no condition, I have 10 choices from 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 choices. But I cannot, since we do not have to repeat the digit, that means we cannot use the digit that we have used at the first place. So now how many choices I have? In all I have 10 choices, but I cannot use the digit which I have already used. So still I have 9 choices, right? Why these two quantities are same? Because here we haven't used 0 and here we have used 0, but we haven't used the digit that is has come here already, right? So for second place we have 9 choices. Now again, third place we have 10 choices, but we cannot use the numbers which have already come over here at these two places, right? So now we have 8 choices. For this place we have 7 choices and for this place we have 6 choices. So in all, first digit can be filled up in 9 ways, and just concentrate on and. Second digit can be filled up in 9 ways. Third digit can be filled up in 8 ways, and fourth digit in 7 ways and 6 ways, right? So the answer is 9 into 9 into 8 into 7 into 6, right? So the multiplication of these is that you can do, it's 2, 7, 2, 1, 6, right? So this is the number of 5-digit numbers when each digit is different, and we calculated the total number of 5-digit numbers, that is 90,000. So I asked you 2 questions. Now the third question is, how many 5-digit numbers are there when at least one digit is repeated? At least one digit, right? We do not want each and every digit to be unique. So at least one digit is repeated. Right? Now, how do we calculate that? There are various options: 3, 2, 2, 7, 5. This is applicable. 3, 2, 2, 2, 2. This is applicable. So good number of numbers are there. So we cannot calculate them manually. Now, how do we approach this problem? See, in all, we have how many 5-digit numbers? 90,000. Right? Now we have 90,000 5-digit numbers, and we have 27216 5-digit numbers when there is no repetition, right? No repetition at all. That means in the difference, that is 90,000 minus 27216, the remaining numbers will have at least one repetition, right? Because we have taken all the numbers of 5-digit, then we deducted the number in which there is no repetition of digit. That means in the remaining numbers there is at least some repetition, at least one digit is repeated, right? Maybe one, maybe more than one, right? But at least one digit is repeated, right? So 90,000 minus 27216, so it is 62784, right? So I hope you are clear with this funny, interesting and easy question. Friends, in this session I have discussed the concept of factorial, and I discussed principle of counting as well. In the next session we will be taking some problems based on principle of counting. So do revise this session before you come to the next session, right? Bye bye.